Hey, hi. This is, I'm trying to open this lid of this container by this pen. So basically I am using this, this spoon. Basically I am using this spoon as a lever to open this lid. So it's open now. Paint box. So we use different kind of things like a simple rod or anything to pick up anything. That time we use that rod as a lever. Here I use this spoon as a lever, where this part where I was pushing was an effort, whereas this part where it was taking it up was the load, and the fulcrum was the lower part which was giving the support, and it helps it to rotate upward. So I use this spoon as a lever. You also use many things as a lever in your daily life. People use a long stick to pick up or roll any stone. Even you can use your hand as a lever. You can see when I pick up this, I put my hand over here and pick the things, like you might have seen someone picking in gym. So over here, this lever, this place is your fulcrum, here is your effort, whereas load is by inside your hand and you're using your muscles. That is basically effort. This spoon is load, whereas the air here it is effort, because load whatever work and whatever you are picking up. So your hand can be used as a lever. Now for this there is a law for lever, that is effort into effort arm and multiplication of load and load arm are always equal. Okay, so over here lever, the fulcrum can transfer from one place to another place, and the lever can be classified in different types, like first class classes, second and third. We will be learning about first class lever and we'll be doing experiment that side. So I've taken this screwdriver and this scale, and I'll put this in the center. It's on 15. You can just adjust accordingly where your scale get adjust. Small errors can occur, but my this screwdriver, when I keep it in 15 in the center 15, okay, it get balanced. It just get balanced at the 15. Why I have taken screwdriver not pen? So that I have taken screwdriver not pen, so that there was pen is a little bit smaller. So I'll adjust this my phone over here. Okay, let me adjust the phone. Okay, so I've taken screwdriver so that I can adjust it. It's a little bigger, wider than pen. Pen is a little hard to do balance. So I've taken a screwdriver and kept it in between. Now I'll take tape, whatever tape you have, you can use. I'm applying it between this screwdriver so that when I keep it downward, it should not move here and there. It should be balanced on the particular place. Okay. So I'll just press it so that it get balanced. Okay. Now let's check once or twice whether your one is balancing or not. So let me stick it from here, and then I'll check whether it's balancing or not. I need it to be balanced. Okay, you can see it's balancing. means it's on a particular place, stopped on a particular place, not moving here and there. See, if I keep one coin, then it goes on one direction, or again if I put another coin on the another, it again get balanced. You can see it. Okay, so I made this assembly. You can see if I put two coins, this is exactly, if I put two coins on the one side and two coins on the another side, equal distance, so it again get balanced. So you have to keep in mind that you make this assembly, just adjust accordingly, because sometimes some errors can occur. Your maybe scale is like this broken one, so it will not adjust on the center. You have to adjust in somewhere where this will be adjusted. Okay. Here is the assembly I made. Now, as I've shown you already, that I've taken these 10 coins which I weighed, and 5 gram is the weight of every coin. So what I'll do, I have written these formulas over here. You can see load into load arm, effort into effort arm, as we have discussed, same. So what I'll do, I'll write the load over here, how many coins I have used, length of load arm I'm using, and then effort into effort arm, and then we'll check whether the formula is correct or not. So one coin weigh 5 gram. Now 5 grams I'll keep. Let's start with the one. So this I have kept on the one corner. So now I'll measure the distance between, so that you can come to know whether, but it's around 15. Okay, so okay, one thing I'll do, I'll mark this on center. This is, I guess, is a center. Not exactly, some errors can occur because these are not perfect devices we made at home, of course. So this measure I take, it's around 15 centimeter. If you can see, it's around 15 centimeter. Let's keep it a little forward so that I can make it 15 centimeter. Let me check whether the scale is properly, both sides is equal or not. This side it's 16 centimeter, this side it's okay, a little extra is there. So let's change a mark a little bit over here. I'll take mark from here. Okay, now I've taken this. You can see the distance of this is 15 centimeter, around 15 centimeter. Okay, right. So as you can see, the distance is around 15 centimeter from the mark. Okay, I'll take it over here, 15 centimeters. Now I'll keep two coins this side, and of course this will go inclined toward that side. First I'll write this. Let's say this one is load, the one is load. So I'll write this load is 5 gram. Okay, basically we don't write 5 gram, we write 5 gram force. Okay, because 5 gram is mass, 5 gram force is weight. And then I write load arm is 15 centimeter. So you can see this will become 75. 15.5 is 75. Now we have taken this effort 10 gram, because 5 into 2, 2 coins we have taken off 5. So 10 grams. Multiply with the effort arm. So if you can think, so the it should be, how can you make 10 into 7.5 when the distance between them should be 7.5, then it will become 75. 10 into 7.5 will become 75. So distance should be around 7.5. Yeah, a little bit less or more can happen. Let's see the distance first. Let's take it further. Slowly I'll take it further, and you can see it's get balanced again. Now I'll measure the distance between this. So as you can see, it's roughly 7.5. The distance is 7.5. So if I'll write 10 multiplied by
7.5, it becomes 75. So now you can see 75 is equals to 75. It means load into load arm is equals to effort into effort arm. Now what if I'll keep 3 coins over here? So for this side, load is the same of last time, 5 gram force. Again I'm repeating, why 5 gram force? Because 5 gram is a mass, 5 gram force is a weight. This is a unit of measuring weight. Then this was like, and load arm we have the same, is 15. So it becomes 5, let me write formula, load into load arm is equals to effort into effort arm. Now I have this load which is 5 gram force into load arm is, we write unit always, load arm is 15. So ultimately it becomes 75 gram force centimeter because everything is multiplied. Now over here effort I have 15 grams force. Now those, some of you can even think and guess about the distance. Distance should be around 5 because 15 5 is 75. So let's check whether the formula is correct for this again. So 3 coins I have put it over here, you can see, and I'll start shifting it slowly. Let's see where, see it's not balanced yet, so I'm not doing anything, I'm just shifting it forward and it gets balanced. So let me put it properly. It's not balanced, okay, it's balanced. So let's take a rough distance of this. So as you can see, the distance of this is 5 centimeters, 0 to 5 centimeter. Roughly distance, because rough distance from this also. Even I have not started at the end of this one. You can check out this one also again. If I'll take from here, it's 15 around, approximately 15. Okay, not exactly. So effort arm is 5 centimeter. So it becomes 5 gram, 75 gram force. Now you can see the formula is correct for these all things. These kind of things we use in seesaw. If you can see the two equal, you can see these kind of assemblies in seesaw. Where seesaw is, this is a fulcrum. Of course, this is a fulcrum, the central part where this is rotating. Seesaw have these 2 and 2 over here, and you can sit accordingly. If your weight is high, you put sit over here, and the another one is low, then they put sit over here. So here these kind of things works.